I thought it'd be interesting to talk about the solar system today. I had, okay, take two.
This is a Lazy Teacher podcast.
Welcome to the Lazy Teacher Podcast. My name is Brian Pulowski. This is episode 8 on the solar system. Welcome back to the Lazy Teacher Podcast. I thought this episode would be kind of an interesting one to talk about the solar system. Growing up with my dad, he used to always take me outside and show me meteor showers, and we'd go camping, go fishing. And it was always about like looking up. Like I just remember that as a kid, like everything was, look up. And I think that's awesome because it really instilled in me this fascination with space and the solar system. And I think it's awesome. So what I thought would be a good idea was to kind of just like explore some cool ideas that are happening in the solar system, and maybe some things that you guys aren't aware of, maybe some things that, maybe you know about, maybe you don't, but either way, I always thought they were kind of neat. And so I just kind of like thought it'd be cool to go into that. So we could start with like our closest neighbor. So the closest neighbor to us would be the moon, right? So the moon's not too far away from us. The moon is a quarter the size of the Earth, right? So if you take the Earth and chunk it out into quarters, the moon is 1/4 of that size. Well, where'd the moon even come from? All of these things, it's hard to know. You can't know for sure, but the idea of where the moon came from is that, when everything was kind of forming in the solar system, you had this like big globule of like gelatinous Earth, right? And then at some point, things are colliding, things are breaking up, and things are forming. And there was something roughly the size of Mars, as they say, hit into Earth. And that sends off this like just big chunk of this gelatinous forming Earth, and it went spinning off, right? But it wasn't so far or hit so bad that it went and escaped from Earth's gravity as it had it, right? So you take this chunk and it starts circling around like Earth is, and Earth forms into this ball, and so does this gelatinous little mass. And it starts circling around and it forms into what is now our moon. If you did like soil samples and whatever of the moon, you'd see that, it has like a lot of like the same substrate and stuff that Earth has. Not identical with everything, but maybe just enough in what Earth was forming, and to make like, a section of it just kind of went off into space. And that's like a whole different episode if we want to go into the moon. The moon's amazing in what it does for us as far as tides and everything, but that's a whole new issue. So we can, that's kind of where we can go from there. If you wanted to start from like our star, the sun, which I can go on and on about this. We only have one star. Most solar systems in space actually have two, right? They're a binary star system. So that's just a little like tidbit of information. But so our solar system, obviously only one star. The closest planet to the star, our sun, is Mercury. And Mercury is a fascinating one because being the closest, you would think the heat source for our solar system is the sun. You'd think being closest to the sun, it would be the hottest of the planets. Turns out Mercury is absolutely not the hottest planet in the sun. We're going to get to that planet in a little bit, but it is the closest. And being the closest, it's charcoal and gross and disgusting, and it's shrinking. How do they know it's shrinking? Well, a long time ago, they sent a satellite out to visit Mercury. All the planets have been visited, or at least had flybys and taken pictures or videos of them or whatever. And when they did that for Mercury, they realized that they could they circled Mercury for so long that they were able to calculate the size of Mercury and see that it was our smallest planet. But since then, they've been able to go back and check it out, and they've seen that it's shrinking. How much? Truthfully, I don't know. And this is all just like, lazy teacher science. I don't know like specifics on this. This is just all like what I hear, what I read, things that I've kind of like mildly studied at best. But Mercury is shrinking. Kind of an interesting little thing right there, right? Okay, so the next planet out after Mercury is Venus, and Venus turns out to be the hottest of the planets. Why is it hottest? Not by proximity. It's not closest to the sun. We already established that Mercury is the closest planet, but Venus is the hottest because it has this like super high pressure, bizarre environment, that atmosphere that keeps the heat in, right? So you think about your car. When you go out, in your car, like in the summertime when it's the hottest, if you keep your windows closed and you go out to your car after it's been in the heat for a while, like maybe you went shopping or something like that, once you get in your car, do you realize that your car is hotter than it was outside? Well, the reason for that is because your windows allow for the heat from the sun to come through the windows, and then they trap it inside your car. Well, that's exactly what Venus does. It has this crazy, bizarre environment where it's trapping the heat inside. So it's hotter than Mercury, which is the closest planet. But this environment, this atmosphere, traps all the heat in, and it's crazy, right? It also has super high winds. I could totally be wrong. Lazy teacher science here. I think the winds on Venus go like 50 times faster than the rotation of Venus. That's amazing, right? So it's either 50 miles an hour or 50 times faster than the rotation of the planet. I'm going to go with 50 times faster than the rotation. I could totally be wrong there, but Venus is an interesting one in that. Okay, so let's go to the next one out. The next one out is us, right? We're the third rock from the sun, as that TV show goes. So that's Earth. We know a little bit about Earth. We can always come back to this one if we wanted, but we're going to go to the next one out. The next one out is Mars, and Mars is awesome. Mars is red. That's the planet that they talk, well, let's go visit, let's colonize it. Little known fact, or people don't maybe realize this, is the astronauts that they're planning to go out to Mars, maybe they're gonna have to jump. They're gonna have to do a little puddle jump from Earth to Mars, and then from Earth to the moon, and then from the moon they can jump up to Mars based on like gravitational pulls of planets to help pull them out there. But they are gonna have to go from Earth to Mars, Earth to the moon, and then moon to the Mars. But they're not coming back. Right? A lot of people say, oh, that's kind of an interesting thing. I would do that. I'd go to Mars. Well, maybe you would, but you wouldn't come back. They can't plan a trip to come back. They can get you there, and then they want people that are going to colonize and try and live there. So that's kind of beyond the point of what I'm talking about. Mars is interesting, though, in that Mars has the largest volcano in the entire solar system, right? So that's Earth included. So let me back up a little bit and say the largest volcano that we're aware of. Okay, this large volcano is called Olympus Mons. It's huge. It's so big. I believe it's like 370 miles across. That's ginormous. That's more than the state of Arizona. Excuse me. That's more than the state of Arizona. It's huge. It's all the way across, right? It's so tall. I believe, I got to think about this. I think it's 15 miles high, right? From the base all the way to the peak. I believe it's like 15 or 16 miles high, which is triple the height of Everest. Mount Everest, that's our highest mountain on Earth. And Mars just far surpasses that. It's, Olympus Mons is huge. It's gigantic. So not only does it have the highest volcano, highest mountain in our solar system, but it also has the longest and the widest valley in the solar system. And I gotta think. I believe the name of this valley is it's like, I'm gonna say this wrong, Valles Marineris or Marineris or something like that. It's super. I do know that's over 2,000 miles long, 2,500 if I can remember correctly, 2,500 miles long, right? That's 10 times longer than the Grand Canyon. Okay, going back to comparisons of Earth and our friend planets. So Valle Marineris is the longest valley in the whole solar system, and it's 10 times longer than the Grand Canyon, which is clearly the biggest valley on Earth. It's huge. It just makes the Grand Canyon look so small, which is it's one of prides on Earth. But yeah, Mars, biggest mountain, longest, deepest valley. Amazing. Mars is crazy. Okay, so we've gone from Mercury to Venus. Earth, kind of skipped over Earth. We know a little bit about Earth being that we live there, right? So then we went into Mars. After Mars, we have this giant belt of rocks and obstructions and craziness and miniature planets and stuff. And that's the asteroid belt. And the asteroid belt is crazy, right? So as our solar system's forming, you have all these rock planets, Mercury, Venus, Earth, Mars, and anything that was left over, all the trash, the debris that couldn't come together and coalesce and make a planet, turned out to be like just this leftover garbage. And this is the asteroid belt. So you have four rock planets and then all the little trash. And that's the asteroid belt. And inside the asteroid belt, we have some dwarf planets, we have Ceres and some things that would qualify. They'd qualify as far as size to be a planet, but they're not a planet. And we'll get to that when we get to the end. Okay, so after the asteroid belt, we have, oh my goodness, the largest planet in our solar system, and that's Jupiter. And Jupiter is ginormous. It is so big. If you took every single planet in our solar system, and you squished it and you just made them all into a big ball, well, that big ball wouldn't be as big as Jupiter, because Jupiter is just that big. And once it gets to a certain status, it can actually, kind of compress into each other with its heat, and it explodes into a star. But Jupiter didn't reach that stage, but it is ginormous. It is so big. It's bigger. It's way bigger than even our second biggest planet, which is Saturn. And Jupiter is just fascinating like that. Jupiter has all kinds of moons. They keep finding more and more moons on or going around Jupiter. And I believe at last count, it's like something like 60-something moons going around Jupiter. One of those moons is Europa. And Europa is crazy because what they believe is underneath the surface of Europa, they believe is liquid water. Okay, now is it pure water? Like, again, I got to backstep and say, lazy teacher science here. I don't know exact specifics. Liquid something. They believe it's water. And one of the main reasons that they think it's water is because it's constantly changing, right? So similar to Earth in that if you took a picture of Earth from space and then maybe in 100 years took the exact same picture, the exact same location, the rotation was exactly the same, Earth would look a little bit different. And that's because we have tectonic plates. These plates are moving with earthquakes and volcanoes, and things are always changing the surface, reforming the surface of Earth. And that's what Europa has. So extremely fascinating. There's plans for, maybe landing on Europa. Is there like maybe a hot drill bit go through the ice core to get to liquid? These are just ideas that are put out there. But if they could get through the outer shell of Europa, they believe there's liquid, and they believe it's liquid water. So it's just amazing. And this is on this is on Jupiter. And again, 60-something moons of Jupiter. It's just crazy. Jupiter has this large red storm, the giant red storm of Jupiter. Red storm so big, I think that red storm is bigger than Earth. You could take Earth, try and put it on that red storm, and I believe that red storm is bigger than even our planet Earth. It's just fascinating. That's just how big that Jupiter is. I mean, you couldn't even imagine how large it is. They try and make pictures and size comparisons, and nothing really does it justice because Jupiter's just large. It's so big. You just really can't portray how big it really is. This storm that's happening and circular that's happening on Jupiter is so big that the planet Earth could fit on that. And that's just a small fraction of the planet as a whole, right? Okay, so moving out, after Jupiter, we have Saturn. Saturn has those beautiful, beautiful rings. One of the reasons why it has those rings, well, there's many reasons. One reason we can see those rings so well is because it's frozen ice and water. And as we know, ice is reflective. And so it reflects the light of the sun, and we can see those rings. All the planets have some sort of ring system. It doesn't. Not all of them are obviously ice where it's reflecting the light, but you can see some. You can't see them all. And Saturn has those big, beautiful rings. Well, okay. So if it's ice, doesn't it melt over time with the sun? It does. It actually does melt over time. But what's interesting is one of the moons of Saturn, and I'm going to say this wrong. I think it's Enceladus or something, and Enceladus, something like that, has volcanic volcanic volcanoes, right? On Enceladus, and it's amazing. And they have pictures. They have so many pictures of this moon around Saturn. And what they believe is as this moon is orbiting around ginormous Saturn, it's flexing, right? Because it gets close and then it comes out of orbit just slightly, and the pressure differential from the gravity squeezes it, and it goes in and out. And they believe what it's creating is this heat, but it's pushing out what they're not certain of. And it's creating vapor, water vapor, right? So we have more water in our solar system, which is just another, fact that doesn't get spoken of too much, but there's tons and tons of water in our solar system. And that's what they believe. They think that the flexing as it orbits around Saturn, they believe is causing the pressure that makes these ice volcanoes, right, to erupt, and that ice shoots out and it replenishes the rings of Saturn. So pretty cool in that, right? Okay, let's move out our gas planets. We went from Jupiter to Saturn, and then we're going to go to Uranus. Uranus is, I don't know if I have a favorite planet, but Uranus might be one. One strictly just because of the name, right? Like so many people call it Uranus. I'm so used to saying it the correct way. Most people say Uranus. Well, it's not that. It's actually pronounced Uranus, and Uranus is awesome because if you take the 8 planets, they all orbit and rotate at the exact same distance. Or I'm sorry, not the same distance, the same revolution. Right? They all go the exact same way, except one, Uranus. Uranus does not rotate the exact same way. What it does do, well, we'll get back to that. There's two planets that don't rotate the same. One is Uranus, and Uranus doesn't rotate like this. It doesn't spin like normal or rotate like Earth like normal. What happens is they think that, again, something the size of Mars hit it and knocked it over. And so its axis, its poles, you guys are familiar with that, North and South Pole, its access points are almost completely in a horizontal plane with its orbit. So instead of rotating as it's orbiting around the sun, it's actually laying on its side and it's rolling around the sun. Okay, so it's kind of interesting. So if you take the South Pole is always facing the sun. So the North Pole, well, I shouldn't say it. Let me change that. The South Pole is not always facing the sun. For a great majority, the South Pole is facing the sun, but you have the North Pole that does not see the sun very often. And it has, I think 22 years of darkness or no sunlight on the North Pole. So it's very fascinating. So Uranus actually is rolling around the sun, which is totally contradictory to every planet that we have, except for one. Let's go all the way back to our rock planet, Venus. Venus does rotate similar with a North and South Pole, but Venus is totally upside down. North Pole's up, South Pole is down for every planet except for Venus. Again, they feel like maybe when all these planets were forming, something hit Venus, knocked it over upside down, So it orbits in the same path as all the planets, but it's rotating backwards. So that's where they kind of feel like, if it's supposed to rotate this way when it's upside down, it's still going around. It's orbiting the sun in the same path, but it's spinning backwards. And so what they feel like is maybe it got hit and turned upside down. Okay, jump all the way back to Uranus. Uranus is rolling. Those are the two planets that rotate oddly, I guess you could say, around our sun. After Uranus is Neptune, and Neptune is this just giant gassy ice planet. It's frozen, similar, right? Because we say it's ice, but it's huge. It's huge. It's a ginormous, big planet, and the light from it can vary depending on the temperature of it. And I got to think about this, but if I recall correctly, I believe that Neptune radiates more heat at its core than it's actually collecting from the sun. And that's rare. That doesn't happen very much, because even though Neptune's way out there and much further away from the sun than we are, all the planets are still collecting more heat than they actually radiate from, or they collect more heat from the sun than they radiate from their internal core, except for Neptune. Maybe it's because Neptune's one of the farthest planets out there, or is the farthest planet out there. Hard to say. I'm going to keep jumping back to this. This is all like lazy teacher science here. This is a fascination with the solar system, and facts might be in and out and wrong and right, but I believe I'm telling you all of this right. So that's our 8 planets. We used to have a 9th planet. Okay. And that's Pluto. Well, Pluto is no longer a planet. Okay. Why is Pluto not a planet? Kind of hard to say. Forever and ever it was, but then they kind of realized, okay, hold on. There's other big objects that are almost the same distance away from the sun. All right. Well, if there's more objects that are, equivalent about as Pluto from the sun, then why are those not planets? So then they had this big committee, and they had to establish what makes a planet. Okay, so then they kind of came up with a criteria. And unfortunately, this is where Pluto lost out, is because they had to make a criteria for what makes a planet and what made a planet. Well, Pluto didn't work for that. Okay, so the first thing to be a planet is you have to be so large that you create a gravity so strong that you become a sphere. This goes into physics and could be a different episode, but all matter, all things that you can touch have some sort of weight to them. They have some sort of gravity. They actually have a gravitational pull. Everything from your car, clearly, which is difficult, if not impossible to lift, to a feather, which is extremely light, but a little bit bigger. But everything has gravitation to it. Everything has a gravitational pull to itself. Well, when something is so big, its gravitational pull sucks it into like a sphere. So that's the first criteria of being a planet, is you have to be so large that your gravity pulls you into a sphere. Okay. So once you're a sphere, now you have to orbit around the sun, right? So we have two things that objects do. They rotate, and then they also go around the sun. When you go around the sun, that's orbiting the sun. Well, when you're a large object, you're a sphere, it kind of naturally goes with it that you rotate. It just happens. That's the physics of it, is when you become so large and you become a sphere, you just rotate. Well, your rotation also needs to orbit around the sun. Okay, so now we have so large that you become a sphere, and you also have to orbit around the sun. And Pluto qualifies. Pluto is absolutely a sphere, and it definitely orbits around the sun. But unfortunately, here is where Pluto loses out. Pluto does not do what they call clear its orbit. Okay, so when you clear your orbit, that means as you go around the sun, there's nothing in your way. or if there is something in your way, it's nothing that's going to stop you or impede you from moving. If it hits you, it's not a big deal, So let's take our Earth as an example. Earth, as Earth rotates around the sun, every once in a while something comes into our orbit, and our gravity pulls it out of the way or pushes it out of the way, or sometimes it just hits us. If we're unlucky, it'll hit us. But Earth has a clear orbit. Now, the moons don't count because the moons orbit around the planet themselves. So that's kind of like a caveat of this, is that you can have moons. You can be so large that you've collected little friends that go around you. But overall, as you go around the sun, you have to clear your orbit. You can't have anything in your way. And that in lies where Pluto is not a planet, because Pluto is in this big belt system, similar to the asteroid belt that we talked about, where the rock planets formed, and anything that was left over became like this belt system of leftover rocks. Well, when the gas and ice planets formed, anything that didn't form into a planet also got made into like this little like debris trash field, a belt system, and they call that the Kuiper Belt. And inside the Kuiper Belt is Pluto. Well, along with Pluto, a big object that is a sphere that orbits the sun is also big spheres that also orbit the sun. So Pluto is certainly not the largest object in the Kuiper Belt. It's not. There's a lot other. So if Pluto is a planet, then we're going to have to qualify a lot of other planets. We're going to have to state that these other objects in the Kuiper Belt are also a planet, and so that's a large distinction. We'd go from 8 planets or 9 planets if you wanted to include Pluto to possibly 20, 30, and they didn't want that to happen. It needs to be an elite group, as they like to call it. So that is why Pluto is not a planet, right? It's big enough that it's a sphere. It does orbit the sun, but it does not clear its orbit. And that is, that's the largest problem right there. So we've kind of reached the edge of, just basic solar system. Our solar system definitely does not end at that point. In fact, if you go past the Kuiper Belt, you go much, 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 much farther, further than I could even describe to you before our solar system ended. So a lot of people feel like the edge of the solar system is our last planet, or the Kuiper Belt, but it's not. There's a big cloud system called an Oort cloud. And I am not going to get into the details of that in this episode, but essentially the Oort cloud is, if you imagine like a beach ball, okay? Inside this beach ball, take a big beach ball and then take like a tennis ball. If you could put that tennis ball inside the beach ball, that tennis ball would represent what we kind of are familiar with of our solar system. There's inside that tennis ball would be the sun, and then all of our planets, and then maybe the outside fuzzy green part of the tennis ball would be the Kuiper Belt. Well, imagine that small tennis ball inside a big beach ball. Well, that big beach ball would represent the Oort cloud, and it's all encompassing. It's spherical all around us, and the Oort cloud is where most of the comets come from, and there's I keep saying this, but there's like a whole different and a whole new episode on the Oort cloud as well. It's super fascinating, and I just love to talk about it. So, I guess that's where this episode came from, is just kind of like expanding and wanting to talk about maybe a little bit something outside the classroom and in different things. I don't know. Maybe you have a different fascination or something you're interested in. If you want to let me know about it, maybe we could talk about it. Maybe I could look into it too. Like, I love picking up new hobbies and new interests. I'd love to hear about it. My email is Brian, Brian, at thelazyteacherpodcast.com, or you can leave me a comment below in YouTube if you're watching this on YouTube, Or you can go to iTunes and subscribe and rate and review. That would help me tremendously. I can't even explain to you how much I need that right now at this beginning stage of launching this podcast. That ratings and reviews help so much. Like you need to get high. You need to get high in those categories on iTunes. And it's going to help out. So if you want to help me out, I would really appreciate it. Or you drop me an email or drop me a comment, anything. I'd love to hear some feedback. It's been interesting, and I was super excited to do this episode, and I think it worked out good. So I hope you enjoyed it. I know I enjoyed it. I could talk forever and ever and ever about this topic. So it's been a good time. So this is the Lazy Teacher Podcast. My name is Brian Pulowski. See ya.